Space. It's a big place, isn't it? Honestly, it's bigger than you can possibly imagine. Think of the biggest thing you can, like a mountain or an ocean. Now imagine that's just a tiny speck of dust on a beach that stretches on forever. Out in that vast, dark emptiness, you've got these incredible islands of light we call galaxies. Each one is a swirling city of billions upon billions of stars, all held together in a silent cosmic dance. Our own galaxy, the Milky Way, is one of them. It's our home, a spinning disk of stars, gas, and dust, so huge it takes light 100,000 years just to cross from one side to the other. Within this grand cosmic dance, everything is in motion. Stars are born in fiery clouds of gas, live for billions of years, and then die in spectacular explosions that seed the universe with the building blocks of new stars and new worlds. Planets spin on their axes and circle their suns in a rhythm that has gone on for eons. Moons orbit planets, and entire solar systems, like our own, are slowly, majestically circling the massive black hole at the center of our galaxy. We're just tiny passengers on one of these dancing worlds, lucky enough to have a front row seat to the show. This constant movement means that things sometimes get a bit close for comfort. In this massive, moving, and sometimes chaotic universe, what happens when one of these stellar families, a solar system much like our own, wanders into our cosmic backyard? So, what is our solar system really? Let's break it down. At the very heart of it all, we have the Sun. It's a star, a massive, burning ball of gas that's been the boss of this neighborhood for about 4.5 billion years. It's so big and powerful that its gravity, this invisible force, holds everything else in place. Think of it like a giant campfire that not only gives us light and warmth, but also keeps everyone from wandering off into the cold darkness of space. Orbiting this magnificent star, we have the planets. There are 8 of them, each unique and with its own personality. You've got the small rocky ones up close to the Sun, Mercury, Venus, our own Earth, and Mars. Then you move further out, past a big belt of space rocks called the asteroid belt, and you find the giants, Jupiter, Saturn, Uranus, and Neptune. These are massive worlds made mostly of gas and ice, with swirling storms and rings of breathtaking beauty. But it's not just the Sun and the planets. Our solar system is full of other smaller bits and pieces. Most of the planets have their own companions, which we call moons. Earth has one, a familiar face in our night sky. Beyond the planets, there are even more mysterious realms. You have the Kuiper Belt, a distant icy region that's home to dwarf planets like Pluto. And then, surrounding everything, like a giant ghostly sphere, is the Oort cloud. So you see, our solar system isn't just empty space with a few balls floating in it. It's a complex, busy, and beautifully balanced system. Everything has its place, its orbit, its role in the grand design. It's like a perfectly crafted watch, with each gear turning in harmony with the others. For billions of years, this delicate balance has been maintained, allowing life to take hold and flourish on our little blue and green world. But what happens when an intruder, a rival king with its own court of followers, threatens to shatter that peace forever? Imagine looking up at the night sky at the familiar patterns of stars we call constellations. They seem fixed, eternal, but over many, many years, astronomers would notice something new. A star, once just a faint pinprick of light, would start to grow brighter. At first, it would be a subtle change, something only the most powerful telescopes could detect. But as the centuries rolled by, it would become unmistakable. This newcomer wouldn't just be a star passing by at a safe distance. Its trajectory would tell a terrifying story. It would be on a direct course to pass right through our solar system. This isn't just a star, it's a star with its own family, another solar system hurtling towards us. The approaching star system might be a bit like ours, or it could be completely different. As it drew closer, it would become a prominent feature in our sky, a second sun perhaps, casting strange double shadows across the landscape of Earth. The nights would no longer be truly dark, lit by the eerie glow of this celestial intruder. The news would spread across our world like wildfire, a mix of awe, excitement, and deep primal fear. For astronomers, it would be the event of a lifetime, a chance to witness celestial mechanics on a scale never before seen. But for everyone else, it would be a source of profound anxiety. The very foundations of our world, the predictable rising and setting of the sun, the familiar phases of the moon, the reliable turning of the seasons, would all be under threat. Humanity would be united by a single, terrifying question: what happens next? The approaching system wouldn't arrive silently. Its influence would be felt long before it got here. The first messenger of its arrival would be gravity. Gravity is a force that reaches across the vastness of space. The delicate gravitational balance of our solar system, the intricate web that has kept planets in their orbits for billions of years, would start to fray at the edges. The approaching star and its planets would begin to pull on the outermost members of our family, and the first signs of the coming chaos would begin to appear in the farthest, coldest reaches of our home. The first part of our solar system to feel the touch of the intruder would be the Oort cloud. This is that giant spherical shell of trillions of icy comets that surrounds us, way, way out past all the planets. It's normally a very quiet place, a deep freeze where these comets drift peacefully. But the gravity of the approaching star system would act like a giant hand stirring a beehive. It would disrupt the lazy, stable orbits of these comets, sending them tumbling out of their comfortable home. Some would be flung out into interstellar space, lost forever, but many, many others would be sent hurtling inwards, towards the heart of our solar system. The first wave of the invasion wouldn't be planets, but an army of comets. As these comets fell towards the sun, our sky would put on a spectacular and terrifying show. Night after night, the heavens would be filled with shooting stars, not just one or two an hour, but hundreds, thousands. They would streak across the sky in a relentless, beautiful, and deadly display. These wouldn't just be small meteors burning up in our atmosphere. These would be massive chunks of ice and rock some miles wide. The outer planets, the gas giants like Jupiter and Saturn, would bear the brunt of this initial assault, their powerful gravity fields mopping up many of these incoming projectiles in colossal fiery explosions. But the giants couldn't catch them all. The inner solar system, our home territory, would become a celestial shooting gallery. The moon would be pummeled, its ancient quiet face scarred with fresh bright craters. Mars, Venus, and Mercury would all suffer a similar fate, and Earth would not be spared. Our planet would be subjected to a bombardment unlike anything seen since the early days of its formation. While our atmosphere would protect us from the smaller pieces, the larger comets would punch through, creating devastating impacts. A single large impact could trigger mega tsunamis, global firestorms, and a nuclear winter effect that would blot out the sun for years, threatening all life on the planet. This initial phase would be a long and brutal war of attrition. For centuries, perhaps even millennia, as the two systems drew closer, this reign of comets would continue. It would be a time of immense hardship and uncertainty for any life that still existed on Earth. As the invading star system pushes deeper into our territory, the chaos in the Oort cloud escalates from a mere disturbance to a full-blown storm. The gravitational pull from the approaching star and its planets would become the dominant force, overriding the gentle influence of our own sun. Imagine a calm lake suddenly being tilted on its side. All the water rushes out in a chaotic torrent. That's pretty much what would happen to the trillions of icy bodies in the Oort cloud. An unimaginable number of them, like a veritable avalanche of comets, would be dislodged from their ancient orbits and sent cascading down into the inner solar system. The earlier bombardment would seem like a gentle spring shower compared to this new deluge. This isn't just a threat, it's a complete reshaping of our cosmic environment. The number of comets passing through the inner solar system would increase by a factor of thousands, or even millions. They would no longer be rare celestial visitors, but a constant menacing presence. Our night sky would be permanently crisscrossed with their glowing tails, a beautiful but deadly tapestry woven across the cosmos. The risk of a catastrophic impact on Earth would go from being a once-in-a-million-years event to a daily probability. The gas giants, particularly Jupiter, would serve as our last line of defense. Jupiter's immense gravity acts like a cosmic bouncer, ejecting or absorbing many of the objects that threaten the inner planets. In this scenario, Jupiter would become a battlefield. We would witness impacts on a scale that would dwarf the famous Shoemaker-Levy 9 comet collision of 1994. Fireballs the size of entire continents would erupt in its atmosphere, visible even from Earth as bright, fleeting scars on the face of the giant planet. For any civilization on Earth, this period would be the ultimate test of survival. We would need to become a species that lives with its eyes glued to the sky, tracking thousands of potential threats simultaneously. Planetary defense would become the single most important human endeavor. We might build massive laser arrays or fleets of interceptor spacecraft to deflect or destroy the incoming comets, but the sheer number of them would be overwhelming. It would be like trying to stop a flood with a bucket. The Oort cloud's fury would be a relentless siege, a cosmic war that would fundamentally change our relationship with the universe, transforming it from a source of wonder into a source of constant, mortal danger. As the two stars get even closer, the real gravitational tug-of-war begins. The planets themselves, those massive worlds that have been tracing the same reliable paths for billions of years, would start to feel the pull. Their orbits, once nearly perfect circles or ellipses, would begin to stretch and warp. Imagine swinging a ball on a string around your head, and then someone else starts pulling on that string. The ball's path becomes wobbly, unpredictable. That's what would happen to the planets. Neptune, the outermost planet, would be the first to go rogue, its vast orbit twisting and deforming under the influence of the intruder star. If the visiting star passes directly through our solar system, it would create a scene of absolute pandemonium. Planets would be thrown around like billiard balls on a table after a powerful break shot. A planet from the visiting system could pass close to Jupiter, and the two giants would engage in a gravitational duel. They might not collide, but they would drastically alter each other's paths. Jupiter could be pushed into an orbit that takes it careening towards the inner solar system, a terrifying prospect. Or it could be ejected from our solar system entirely, sent off to become a lonely rogue planet, wandering the cold, dark space between the stars forever. The smaller, rocky planets of the inner solar system would be in even greater peril. Without the stabilizing influence of Jupiter in its proper place, they would be at the mercy of these gravitational tides. Earth's orbit could be stretched into a long, thin ellipse. This would lead to extreme climate swings. For part of our new year, we would be much closer to the sun, leading to scorching, unbearable heat that could boil the oceans. Then we would swing far out into the cold, plunging the planet into a deep freeze that would encase it in ice. Life would be impossible under such conditions. The most dramatic and perhaps most terrifying possibilities involve direct collisions. In this chaotic gravitational dance, the paths of planets could cross. We could witness something truly biblical, a collision between two worlds. Venus could be sent on a collision course with Earth, or Mars could be flung into the asteroid belt, triggering an even more intense bombardment. A visiting planet from the other system could even crash into one of our own. The energy released in such a collision would be unimaginable, enough to melt both planets into a single glowing ball of molten rock, a new world forged in a crucible of cosmic violence. The symphony of the spheres would become a cacophony of chaos. For our home, planet Earth, there are very few good outcomes in this scenario. The best case and still terrible scenario is that our orbit is only mildly disturbed. But even a small change could have catastrophic consequences for our climate and ecosystems, which are tuned to the precise amount of energy we receive from the sun. A slightly more distant orbit could trigger a permanent ice age, while a slightly closer one could lead to runaway global warming. The seasons would be thrown into disarray, agriculture would collapse, and the world's ecosystems would unravel. Humanity, and all life on Earth, would face an unprecedented struggle for survival against a planet that is no longer hospitable. A more likely and far more grim fate is that Earth is ejected from the solar system entirely. If a massive planet, either one of our own gas giants or one from the visiting system, were to swing by at the right trajectory, it could act as a gravitational slingshot. Earth would be flung out of its comfortable orbit around the sun and sent hurtling into the blackness of interstellar space. Cut off from the light and warmth of our star, the surface would rapidly freeze. The oceans would turn to solid ice miles deep, and the atmosphere would freeze and fall as snow. The planet would become a rogue Earth, a dark, frozen tomb silently drifting through the cosmic void for eternity. Could life survive such a fate? On the surface, absolutely not. But deep beneath the ice in the planet's core, geothermal heat would still be generated. It's possible that some forms of life, extremophile bacteria and other microbes, could survive near hydrothermal vents on the deep ocean floor. They would live in total darkness, nourished by chemical energy from the Earth's interior, completely unaware that their world had been cast out of its home. It would be a lonely, microscopic existence, a tiny flicker of life clinging on in the heart of a dead world. It's a testament to the tenacity of life, but a tragic end for the vibrant biosphere we know today. The most spectacular and final end for Earth would be a direct collision. It could be with another planet, as mentioned before, or it could be a death spiral into one of the stars. If Earth's orbit is destabilized enough, it could be sent falling towards our own sun to be consumed in its fiery furnace. Or even more dramatically, it could be captured by the gravity of the invading star and pulled into it. In either case, the end would be swift and absolute. Our planet, with its mountains, oceans, and the entire history of life, would be vaporized, its atoms scattered into the plasma of a star. It would be a definitive and fiery end to the story of Earth. What about the stars themselves? The main event of this entire cosmic drama is the close pass of the two suns. Even when two solar systems collide, the stars themselves are incredibly unlikely to actually hit each other. The real battle is not one of physical contact, but of overwhelming universe-shaping gravity. This is the clash of the titans. As the two stars reach their closest point, their gravitational fields would merge and twist in a complex and violent dance. They would pull on each other and on everything caught between them. This is the moment of maximum chaos for the planets. Any world that had managed to cling to a stable orbit up to this point would likely be torn away now. The two stars would effectively engage in a game of planetary theft. Our sun might steal a planet from the visiting star, capturing it into a new, strange orbit. Likewise, the visitor might permanently capture one of our own, like Saturn or Uranus, taking it away as a prize when it leaves. The very definition of our solar system would be rewritten. The stars themselves would be affected. They would pull vast streams of superheated gas or plasma from each other's outer layers. These stellar prominences would stretch for millions of miles across the space between them, creating a spectacular and terrifying bridge of fire. Solar flares and coronal mass ejections would be triggered on an unimaginable scale. After the closest approach, the two stars would begin to move apart, their encounter over. But they would not leave as they arrived. Each star would now be pulling a new, chaotic jumble of planets, moons, and asteroids with it. Our solar system would be a shadow of its former self. Perhaps we would be left with only 2 or 3 of our original planets, now in strange, tilted orbits. We might have a few captured worlds from the other system as well, alien planets that are now part of our new home. The encounter would be over, but the aftermath would be a completely new and unrecognizable solar system, a landscape of wreckage and survivors, forever scarred by the close pass of another star. In the long, silent aftermath of the collision, a new and different kind of order would begin to emerge from the chaos. Our sun, now moving away from the intruder, would begin to reassert its gravitational authority over the remaining collection of worlds. The new solar system would be a mess, but the remaining planets would eventually settle into new, stable, albeit very different orbits. This new system could hold the seeds of a future rebirth. Imagine a rogue Earth, frozen and seemingly dead, that was captured into a new, stable orbit. Or perhaps an icy moon, like Europa or Enceladus, rich in subsurface water, was knocked into a closer, warmer orbit around the sun. Over millions of years, the ice on such a world could melt, forming new oceans under a new sky. The basic chemical building blocks for life, delivered by the earlier rain of comets, would be plentiful. In the warm, nutrient-rich waters of this new world, life could potentially begin all over again. The cosmic collision, an act of immense destruction, could also be an act of creation. Life is resilient. It's tough. If any spark of life survived, whether deep within a frozen Earth or on a displaced moon, it would have a new chance. Given millions of years of relative stability, evolution would begin its slow, patient work once more. New creatures would adapt to the new conditions, the new length of the day, the new seasons, the light of a sky filled with unfamiliar constellations. The end of our world would not necessarily mean the end of life itself, but the beginning of a new chapter in its epic story. And so, even in the face of the most catastrophic event imaginable, there is a glimmer of hope. The universe is a place of constant change, of destruction and renewal. Stars die, but their dust forms new stars and planets. Solar systems can be torn apart, but the pieces can reassemble into new, fertile configurations. Life, once it has taken hold, is an incredibly persistent force. The story of life in our corner of the cosmos might not end with the death of Earth. It might simply be waiting for a new stage to be set, a new dawn to break over the oceans of a different world, ready to begin the grand adventure all over again.